You are welcome. Today we are discussing the physiology of hearing, but before we go to the physiology of hearing, let us look at the structure of an ear. So this is an ear. It's showing the auricle there, okay, and the lobe down there. There's also a tragus. So the ear has three regions, which is the outer ear, is looking in brown, the middle ear in pink or purple there, and the inner ear is in blue. Okay, so there's an auricle there. It's also the external auditory canal, okay, and also there's a tympanic membrane, which where the middle ear begins, okay, and the auditory ossicles, which are the malleus, incus, and stapes. There's also the eustachian tube going down here, and there's the inner ear. There's a semicircular canal, the vestibulocochlear nerve, the cochlea, over window, and the round window. Okay, so now the sound waves are collected by the auricle. Okay, so these are the sound waves collected by the auricle, go through the external auditory canal, which are then focused on the tympanic membrane, which makes the tympanic membrane to vibrate. So when the tympanic membrane vibrates, okay, it will push the malleus, which the malleus will push the incus, and the incus will also push the stapes. So the stapes will push, the vibration will push the oval window to start pushing the perilymph in the inner ear, the cochlea. So this is the cochlea. There's also the organ of Corti, which is the true organ of hearing. Okay, so let's look at the physiology of hearing. Okay, so this is the physiology of hearing. So we are saying hearing is the sensation of sound. The hearing system has two components, namely conductive and sensory neural. The external and middle ear transmits the sound waves as mechanical vibrations. The auricle collects the sound waves, to the external auditory canal, which transmits it to the tympanic membrane. The tympanic membrane vibrates and converts the sound into mechanical vibration of the ossicles. In the middle ear, the ossicles conduct the sound waves from the tympanic membrane to the oval window of the bone labyrinth. Ossicles also magnify the action of sound waves. The middle ear muscles reflexively contract on exposure to loud sound, therefore impeding the vibrations of the ossicles and protecting the inner ear. The eustachian tube ventilates the middle ear to equalize the middle ear with the pressure, with the atmospheric pressure. So this will help the movement of the tympanic membrane, and the ossicles. In sensory neuro, there's a movement of the footplate of the steps at the oval window, which sets in the vibration of the perilymph and the basilar membrane, therefore stimulating the hair cells in the organ of Corti, where mechanical sound vibrations are converted into electrical impulse. In the cochlear nerve, there is a transmission of electrical impulse to the cochlear nuclei, the bones, to the inferior, the colliculus, to the medial geniculate body, to the auditory area of the temporal lobe, to be perceived as meaningful sound. So this is the physiology of hearing. Okay, so this information comes from this book, ENT Perspectives. Remember, this channel is not a substitute of school and the hospital. Okay, so until next time, bye bye.